Hi, so this week we're going to be working on the conic sections, circles and ellipses. So for the first 2 days we'll work on circles. Today we'll do some basics. Tomorrow we'll do some more algebra. Tomorrow it'll be algebraic. Today it'll be a little bit of working on the coordinate plane, working with some formulas, looking at things, and then writing basic equations. Okay, so today's the basics. So you're going to have 2 circle assignments this week and 2 ellipses assignments this week. So make sure that you're staying current and not getting behind. All right, so this is objective 1.2a. This is 1.2 all week. This is just part A. So number 1, essential question, what is the standard form equation of a circle? And number 2, how do I write the standard form equation of a circle if I'm given certain conditions? Okay, so a couple formulas that you need. The distance formula, which is basically the distance between 2 points. So if I give you the point x sub 1, y sub 1, and I give you the point x sub 2, y sub 2, and I want you to find the distance between them. Well, the distance is just the change in x squared plus the change in y squared. It's the square root of that value there. Or in shorter terms, the change in x squared plus the change in y squared, the square root of that value. And if you're wondering what that little triangle means, that's the delta symbol. It's the Greek letter delta, uppercase, and delta says change in, meaning subtract, find the distance between them, change in. Okay, so delta x squared, square root of delta x squared plus delta y squared. So there's one formula. Midpoint between 2 points would be just the average between the 2 points. So you'll take your x sub 2 plus your x sub 1 and find. So average them, just add them and cut it in half. Same thing with your y sub 2, y sub 1, cut it in half, and that'll give you your midpoint. So there's your formulas that you'll be using. Now let's talk about the definition of a circle and the conditions that have to exist for you to write the equation of a circle. So the definition of a circle is this. Definition of a circle is a locus of points. Remember, a locus is just a collection. A locus of points that are equidistant from a fixed point called the center point, the center. Okay, all right, so you just have a collection of points that are equidistant from a fixed point. Okay, they're all the radius away, all the points are a radius distance away from the center point. Standard equation of a circle. Well, let's talk about, let's start with that. All right, so it looks like this. X minus h quantity squared plus y minus k quantity squared equals radius squared. Center is at hk, and r is the radius. Okay, so here's the important thing. In order to write the equation of a circle, you need those 2 things. You need the center and you need the radius. So did you get that? In order to write the equation of a circle, you need those 2 things, a center and a radius. Now here are the conditions that make this equation actually graph a circle and not an ellipse or a hyperbola, and it's certainly not a parabola, right? In order for an equation to graph a circle, here are the conditions that must exist. The coefficient of the x squared and the y squared must be the same. Okay, so the x squared and the y squared both have to have the same coefficient, whether it's a 1 or a 4, whatever, it doesn't matter, they have to be the same. Both the x and the y have to be squared. And their third condition is you have to be adding those 2 values. You can't be subtracting those 2 values. So it's these conditions here, and they equal a number. And you can, of course, rewrite that equation in many, many different forms. But you're always looking for the same conditions, that the x and the y both have, well, the x squared and the y squared both have the same coefficient. They're both being squared, and you're adding their values. Okay, so that is the conditions that create a circle. All right, so let's take a look at where this equation right here came from. Okay, certain ways you can look at it. I think the one that's probably most familiar for you is the equation of the Pythagorean Theorem. You know that theorem that says if this is a right triangle here, and this is point A, this is point B, this is point C, that A and this, so that would be side A, side B, and side C, and the Pythagorean theorem says A squared plus B squared equals C squared. We know this is true. We accept that about all right triangles. Now, so how does that become x minus h squared? So the distance between x and h squared plus the distance between y and k squared equals radius squared. Well, let's say I put right here in the center. Here's the center of my circle. This is the point HK. And here's a radius, right? So I'm going to put that right here. So this is a point P. And you know, I can kind of just rotate that all the way around. This, I can just rotate it all. Point P just kind of randomly rotates all around the circle, right? So it's at, if I'm on a coordinate plane, it's, imagine that I'm on a coordinate plane, that point would be at x, y. That's where that point would be, any random point on the coordinate plane, right? Well, if I were to drop in a vertical distance here, I connected these 2 points, my C point and my P point, right? If I were to connect those horizontally and vertically, and then that is not a very good vertical line. Let me redo that real quick. I don't want to waste your time, but I just really like it to look nice. All right, so that's a right triangle, right? And so the distance between this point here and this point here, this would be y down k. I have to go down from y to k to get that measure right there. And then if I were to go this way, right, because I'm going this way and then I'm going this way, let me change that to red. So I went that way to that way. And now I'm going from this point here to this point here, so I'm going x minus h. I'm going x and then back h, right? So that's x minus h. And here's what we know about this. This is our radius, right? So it's a right triangle. So I pretty much can transfer this information. The bottom, the horizontal quantity squared, I'm going to do this equals plus radius squared, plus the vertical distance change, y minus k squared equals your radius squared. So you can derive the equation of a circle from just the Pythagorean theorem, because you're just measuring vertical distances and squaring them, horizontal distances, squaring them, and adding them and making it equal that diagonal distance, which is your radius. Okay, all right, so let's do a quick practice here. It says sketch or use a compass to graph. All right, so here we have this situation where we have an x being squared, a y being squared. They both have the same coefficient, and I'm adding them. Therefore, this is a circle that has the conditions that create a circle. All right, so this is x minus h squared plus y minus k squared equals radius squared. So what is my center? What is my h? K. Okay, so 1 is my h. And notice that this says y minus k right here, and that says y plus 1. So in order to change this plus to a minus, this has to say minus negative 1, right? Minus negative 1 is the same as plus 1, so your k is negative 1. And here's what we know here. Your radius squared equals 16. Well, we're not looking for radius squared, we're looking for radius. So we're going to have to go ahead and square root radius squared plus minus the square root of 16, but we can go ahead and eliminate negative square root of 16 because distance can't be negative. So canceling, square roots cancel out squares. Radius equals the square root of 4. And so that means that I have a center here at 1, -1, and I have a radius of 4. Now, if I'm just sketching because I don't have a compass, and I don't specifically have one right here, I would just go from my center a distance up 1, 2, 3, 4, a distance to the right 1, 2, 3, 4, down 1, 2, 3, 4, and left from the center 1, 2, 3, 4. And I would just sketch my circle. Now, if you have your compass, I would expect you to get your compass out and just put your stylus on the center and then stretch out to those points you just drew and sketch a circle. All right. So I would expect that you would do that. All right, so that's not perfect, but you get the idea there. So there's a sketch. And again, only do sketches if you don't have a compass. Okay, now let's do some examples. So in all these examples, I'm going to be asking you to write the equation of a circle. So remember that to write the equation of a circle, you have to have two things. You have to have a center, you have to have a radius. And if you don't have those, you have to find them before you can write the equation. Okay, so if we look at problem A, it says I have a center at 5, 0, and I have a radius of the square root of 17. So guess what? I can write the equation in the form x minus h quantity squared plus y minus k quantity squared equals radius squared. And then I'm just going to plug in those values and simplify. And so this is my hk. So I'm going to plug in a 5 for h and a 0 for k. And this is my radius. So I'm going to do the square root of 17. That is not a 17. Oh, I forgot. You have to square it because that value there is r squared, because remember we're doing Pythagorean theorem here. All right, so let's simplify. So if we simplify that, that would be x minus 5 quantity squared plus y squared, because who cares about the minus 0, and the square root of 17 squared, don't forget those cancel each other out, is 17. And so there you have it. You didn't really need to do a sketch or anything to get that done. So that one's done. There's your standard equation for that circle. All right, let's look at B. So B says you have a center at 4, -2 and a point on the circle at 1, -3. So to write the equation of a circle, remember center and radius. Well, here's the problem. I don't have the radius. I have my HK, but I don't have my R. So I could go about this in two ways. One way I could do it is if I have graph paper, I could actually just go, okay, so my center's at 4, -2. And I have a point on the circle at 1, -3, right? And so if this is my center and this is my point, so my circle's doing something like that, do a little bit better job there, then this would be my radius here, right? So I could just go, okay, so the distance between there and there is 3, and the distance between there and there is 1, and you could just use the Pythagorean theorem to find your radius. So it's okay if you want to do that. That would be 3 squared plus 1 squared equals radius squared, or 9 plus 1 equals radius squared, or 10 equals radius squared. So you could do that. If that's the way you want to do it, you could. The other thing you could do is, because this is the center and this is a point on the circle, you just want the distance between those 2 points, right? So you could use the distance formula, which says you're going to find the distance between your x's. So that would be 1 minus 4 quantity squared, right? And then the distance between your y's, which would be -3 minus -2 squared. And you could just use your formula. So that would be the square root of -3 squared plus, we'll change that, -1 squared, which is, the distance is equal to the square root of 9 plus 1, which is the square root of 10. Okay, so that would be your R. That's your R. That's your radius. Over here, I have your radius squared. Okay, so be careful with that. So now I want to write the equation of my circle now that I have a center and I have a radius, or I have a center and I have a radius squared. You decide what you like. The formula goes like this: x minus h quantity squared plus y minus k quantity squared equals radius squared, right? So my hk is at 4, -2, and your r squared, well, your radius is the square root of 10, and your r squared, which we found over here, is 10. So I think I'll just use that value there. So we get x minus our h, which is 4 quantity squared, plus y minus -2 quantity squared equals radius squared. We'll clean that up. Final answer, x minus 4 quantity squared plus y plus 2 quantity squared equals 10. And there's your solution. Okay, so there you go. Next, here we have an equation of a circle, x plus 2 quantity squared plus y minus 1 quantity squared equals 49. And you're going to translate. Translate just means you're going to slide it 2 units to the left and 3 units up. So let's think about that for a second. We're just relocating the circle. We're not changing the size of it. So the radius is going to stay the same. It's just moving to a new location. That's what translated means. And so maybe one thing you could do is just go, okay, well, I'm going to go ahead and take my center for my original circle here, which would be at -2, 1, because that's my hk, right? So -2, 1, and I could just put it right there. So there's my center original, and I could actually take my center and translate it. So I'm going to use my red pen here to translate it 2 units up to the left and 3 units up, 1, 2, 3, and that's going to be my center prime, which means the prime is just kind of like an exclamation point without the dot at the bottom. So C prime just means that I'm relocating. It's not my original, but it's an image of my original. Okay, so what I'm doing is taking my circle that was centered at -2, 1, then I'm shifting it 2 units to the left and 3 units up. And so this center's HK is at -4, 4, right? And so that would be my new HK. That would be my H prime, K prime. Okay? And so I could write my equation. I could just rewrite my equation, and I'll do it in red here. So that one would be x minus -4 quantity squared plus y minus 4 quantity squared still equals 49, because I didn't change the radius. The radius is still 7. I just relocated the center of the circle. So finishing that up, cleaning that up there, that would be x plus 4 quantity squared plus y minus 4 quantity squared equals 49. So that's a pretty simple way to do that. Another way to do it is algebraically here is this: if I'm moving something to the left, I'm changing the x coordinate, and if I'm moving something up, here I'll do it in blue. If I'm moving something left and I'm moving something up, so if I'm moving left, I'm going left 2 units. So that means I'd be subtracting 2 from the x coordinate. And if I'm going 3 units up, that changes my y value, so I'd be pushing that value up. So my new center prime would be at -2 minus 2, -4, and 1 plus 3 is 4, so that would be my new HK. And again, I could just transfer that into the equation. So either way works for me. Hopefully one of those made good sense to you. All right, last one. This one's a little bit more of a brat because you have to work. I don't know why I said brat, but just a little bit. It requires a little bit more work. It says you have points 3, 4, and -1, 0 are the end points of a diameter on the circle. So they're both points on the circle. And so we're writing the standard equation of a circle, which means that we have to have the center and the radius, and we don't have that. We have 2 endpoints. We have a diameter, which means that those points are on the circle. And if we were to find the midpoint of that diameter, we could find the center. That would give us the HK. And then if we take the distance of the diameter and cut it in half, it would give us the radius of that circle. So we could use some algebra there and just plug values into formulas. That would be one way about it. So let's do it the algebraic way first. Okay, so we have the distance. Let's do the distance between, well, let's find the midpoint first. Let's find the center. Okay, so here's what we know. To find the center, we would have to find the midpoint between these 2 points. So we would find the midpoint of our x's, 3 plus -1. Remember, you just average your x's, cut it in half. Average your y's, cut it in half. 4 plus 0, cut in half. Right, and if you don't mind, I'm going to be just a little bit efficient here. So that would be 2 over 2, which is 1. And this would be 4 over 2, which is 2. So that would be our midpoint of our diameter, which would be our center. So there's our HK. So we have the first thing there. We have the first thing. Okay, now what we need is the distance between the center and one of those points in order to find the distance of the radius, right? So this could be a center, and let's just say I want to use this point here at 3, 4. That would be my xy. Okay, so a couple things I could do here. I could go ahead and use the distance formula to help us find the distance between those points. So if I do that, I would say, all right, so the distance would be the distance between here to here. So that would be 3 minus 1 quantity squared, plus the distance between here and here, which would be 4 minus 2 quantity squared. So that would be, if you don't mind, I'm going to be efficient again. That would be 2, and that would be 2. So that would be 2 squared. So the distance of 2 squared is 4, and 2 squared plus 4. And so the distance would be the square root of 8. And the distance is the radius. That's our radius. So our radius is the square root of 8. And so now we have our HK, and we have our radius. And so we could write the equation in x minus our h, quantity squared, plus y minus our k, quantity squared, equals our radius squared. And we get x minus 1 squared plus y minus 2 quantity squared equals 8. And that would be your equation. Now, if you wanted to, instead, that just didn't really jive with you and that's not how you think about things, what you could do is actually just go ahead and start on the graph at 3, 4 and -1, 0. And this would be your diameter of your circle. And you could actually go ahead and just sketch that circle idea there, right? And then what you're doing is looking for the center. So the center would be half the distance up. So that would be, instead of 4 up, you'd go up 2. And then it's half the distance between here and here, right? That's a distance of 4 and 4. So if I go half that, that would be up 2 and over 2, right? And so that would put me at the point 1, 2. There's my center. And then, of course, I could also just go ahead, this is my radius here. I could go ahead and just do 2 squared plus 2 squared equals radius squared. So radius squared equals 4 plus 4, and radius squared equals 8. And so you have your center there. So x minus 1 quantity squared plus your y minus k quantity squared equals your radius squared, and you could write your equation that way. So it just depends on what you like. So give it a go. Don't forget to do assignment 1.2a and get that turned in, and have a really good day.